The next thing we're going to talk about is constructive and destructive interference. So, if you'll remember from last week, we got the result that y of x of t equals 2a cosine phi over 2 times sine kx minus omega t plus phi over 2. When we add two waves with the same amplitude and the same direct or the same velocity, the same wavelength, everything like that. But each with a different phi value where phi gives uh is given by phi 2 minus phi 1, where phi 2 minus phi 1 is the difference in phases of the two waves. So what this ends up saying is that if we have two waves that interfere, then depending on the phase constant at one of these points or at any of these given points, then uh, they're going to either constructively or destructively interfere. So at y max equals 2a sine kx minus omega t plus phi over 2, and then y min is going to be, and I'm talking about the absolute value of y min, or the value of y min, or the minimum value of the absolute value of y, because it goes from cosine goes from -1 to 1. I want to be sure that I'm talking about the minimum value, which is just going to be 0 uh, when we're talking about this. So what this says is that two waves can interfere with each other when they have, depending on the phase of the object. So uh, the way that we find these phases is saying that delta r has to be equal to n lambda with n equals 0, 1, 2, 3, etc. For constructive interference. So if the path that both of these waves take from like one speaker, if one speaker is pointing out here and then the other speaker is pointing up there, then the difference in the radius that each wavelength has to uh, that each wavelength has wave has to go through has to be some uh, sum of n lambda for constructive interference, because when you have some sum of n lambda, then the phase angle between them is going to be either then the phase angle between them is going to uh, be 0. But for delta r equals n plus 1/2 lambda, the phase angle between them is going to be maximized so that it's cosine of phi over 2. So it's going to be equal to 2 pi, or not 2 pi, pi, or uh, 3 pi, or anything that's going to get you a value of cosine of phi over 2 equals uh, uh, n plus 1/2 times pi. So this is going to be your conditions for destructive and constructive interference. Hopefully you'll be able to see why not, if not, or why this is the case. If not, then this is not going to be on the test, but is an interesting problem. So come up to me if you have any questions about it.